Let's talk about Lewis dot structures. Now, Lewis dot structures are based on a element's location within a group. Notice we have written all the representative elements. Did not include groups 3 through 12, 3 through 12 being here, because that is our transition metals, and they do not have normal valence electrons. They have valence electrons, but their number of valence electrons can vary, so we do not do Lewis structures for them. So if we're looking at a regular group 1, the valence electron, we'll use X as our symbol of an element. Any element in group 1 is going to have one dot because it has one valence electron. So group 2 is going to have 2 dots. Now some textbooks will draw it like this, or they'll draw them paired. I only draw them paired if it's happy. And since our group 2 metals are very unstable and they're going to be reactive, I prefer for my students to do this way. But the book is weird. Now, with 3 valence electrons, this is group 13, so we're over in the boron group. They will have 3 dots because they have 3 valence electrons. Notice I'm working around clockwise. Group 14, like carbon, is going to have 4 valence electrons. Group 15 will have 5. Group 16 will have 6. Group 17 will have 7. Now, helium, it is in group 18, but helium is the only noble gas that only has 2 valence electrons. So it will always be represented with this pair because it's stable. And the rest of group 18 will have 8 valence electrons. So if I ask you to do the Lewis dot structure for sulfur, sulfur is in group 16, so it gets 6 dots. If I ask you to do the Lewis dot structure for aluminum, well, we find it on the periodic table. Aluminum is right here in column 13, so it gets 3 dots. And that's all there is to Lewis dot structures for Chem 1.